altitude, which altitude kind of reminds me a little bit of like when you were younger and you needed to know the height of a triangle. They use the altitude to represent the height. So an altitude is just like a line coming out of your top vertex angle of your triangle that comes straight down at a 90-degree angle. It will always have that 90-degree angle. But when we're doing these problems today, if your two triangles are similar, if you have an altitude, then you can say that any corresponding side is proportional. So you can pick whatever side that you're solving for and set it equal to your altitude as a proportion, and you can solve. So I'm going to use the altitudes for one of my fractions. My altitude for the first triangle is BD, and my second triangle is FH. Now, I can pick any side length I want. I can do AB, I can do the base, I can do AC, I could do this side, I could do BC. It doesn't matter, like I said, it just depends on what you're solving for in the question. Just for this example, I'm going to do AB, and what is the similar corresponding side on the smaller triangle to AB? EF. So that's the one I'm going to choose, but like I said, you could have done any of the three. Now, an angle bisector is also a line kind of coming out of that top vertex angle. But instead of coming down at 90 degrees, it just splits your top vertex angle into two congruent angles. So I'm going to use that angle bisector for my first proportion. So my first angle bisector is QS, but what is my angle bisector on the other triangle? UW. So like I said, that's one fraction of my proportion. Then for the other, pick whatever side you want. So I'm going to mix it up a little bit, and I'm going to do QR. So what is the corresponding side to QR on the other triangle? UV. Like I said, you could have done QP, you could have done PR. It just depends on whatever you're solving for your question. But the point is you have to use like your altitude and your angle bisector for one of your two fractions, okay? And then our last vocab piece here, we have a median, which median and angle bisector look kind of similar to each other. With an angle bisector, it cuts your angle into two, but you don't know anything about the bottom chunk. If you look, PS was a little bit smaller than SR, right? So those are not the same. With a median, you are cutting your base into two, but you don't know anything about the angle. So the angle, you don't know if that's cut in half or not. It could not be the same. But you do know that it hits right at that midpoint to give you two congruent segments on the bottom. So a little bit similar, a little bit different. So I'm going to use that median again for my first fraction. So my median is HJ and LN. So when I go to match that, pick whatever side you want. Let's do the bottom this time, just since we did one of each side. So I'm going to do GI. What does that match on the smaller triangle? KM. So as long as it's corresponding pieces, you're good to go. You guys know that proportions have a lot of flexibility to them. So for example, if I just take this last proportion, the other class they did their LN on top, which put their HJ on bottom. That's fine as long as you match them. Since I started with LN, the small triangle, that means when I go to do my second fraction, I just need to put my small triangle on top. But when you cross multiply, you're still matching the same pieces together, so it doesn't matter. Okay? All right, so let's get started on number one. We have similar triangles. So you know that all the pieces are going to be proportional to each other. But we're just going to solve for x, which is whatever missing piece.
Our next is the activities box.
I will unpause it. Thanks. Let's see. Period 6?
Yeah.
I gotcha. You can go. Once you get back, it'll be fixed for you.
Thank you.
Yep. All right. So, number one, looking at your picture here, what type of vocab word do we have? Do we have a median, an angle bisector, or an altitude? Median, and I knew that because they gave me the little tick marks at the bottom. I didn't have any angle pieces, and I didn't have a 90-degree angle marking, so it must be a median. So you have to use that median for one of your fractions. It doesn't matter if you do x over 15 or 15 over x. Which do you want to do? X over 15, just go left to right. So x over 15, but then if I'm solving for x, I already got x in my equations. That part's good. Now I can pick any side I want. They gave me 16 and 19.2. They gave me 24 and 20. It doesn't matter which one you pick, just as long as you're picking the same side on both triangles. So looking at, you started with your x triangle. Do you guys want to do 16 or 19.2? 16. It doesn't matter, you could have picked the 19.2, but since we picked the 16, you need to make sure you're picking the corresponding side from the other triangle. So 16 is, if you look at your similarity statement, ST or TS. So if you look at ST or TS, what does that match on my other triangle? DE, which is 20. So yes, the numbers that you pick, it doesn't matter which one as long as you match it correctly to your opposite triangle. So since I picked 16, I had to pick 20. I couldn't match 16 with 24. Does that make sense? Okay. All right. So when I solve this, what do? Now what?
It says that my code is like inactive and it won't let me do my activity. Like when I click on it, it just brings me to this. And I can't like do anything.
Unnecessary stuff in there. No, doing all that. I was in Texas. We took a tour of town. I sit down for about 5 minutes trying to do it. I'm like, I'm not doing this. It's just like that. It's all wrong. How can you know?
There we go. I don't know why that happened to you, but not to the others.
Sorry.
Okay. Sorry. 2 interruptions. Hopefully we're good now. Did you guys already solve for x?
Yeah.
What did you get? All right, perfect.
Yep.
Sorry, my bad. All right, number 2, quickly. What type of vocab were we given here? Altitude, and you know that because you immediately see those 90-degree angles. So let's use an altitude to create one of our fractions. Do you want 10 over 8 or 8 over 10?
8.
Ooh, we're switching. We're going with 8 over 10. We're going to change it up a little bit. Small to big. So then, if I did 8 on top, what do I want on top for the second fraction? 14, which that was my only option, but it doesn't help just to double check that it matches the piece that we need it to. So LK does match HI, which is what I needed, so we were safe, but like I said, doesn't hurt to check. So when you cross multiply, I have 8x equals 10 times 14. So for those of you who, when I asked, you said 10 over 8, that means you would have had x over 14, but when you cross multiply, you get the same thing. So that's why it doesn't matter which method you choose, as long as when you're matching them correctly. All right, Sorry for going too fast, but do any of you guys have that done already? 17.5, which we are going to get decimals today, so don't let that freak you out. We have any questions so far? No? We're going to jump to 4. 4 looks a little goofy, but really what is 4? It's an altitude. It just looks goofy because it's on the outside, but think about it. If an altitude has to have a 90-degree angle, can I come from angle Q and go to the middle of my triangle and end up with anything that's 90 degrees? No. So again, remember I like to compare altitude to the height of a triangle. You're allowed to represent your height on the outside, right? We've seen that before. So it's the same thing, okay? So my altitude is 12 and 15. Sarah, why don't you set up this one for me? What do you want to set up for your altitudes? First fraction. Okay, so she actually did her sides first, which is okay, but then Sarah, how would you set up the other piece then? Good. So that part doesn't matter. So you could have put 12 over 15 first, but like I said, when you cross multiply, you get the same directions anyways. So we have 15x equals 42 times 12. Bailey, what'd you get?
33.6.
Do we agree?
Yeah.
All right. Any questions? Are we sure? Okay. Moving on to our next theorem. Our next theorem still uses that same angle bisector that we had before, but instead of using the angle bisector as one of our segments, we're going to use the opposite sides. So notice that this picture here for your triangle angle bisector theorem, there's one big triangle, right? Compared to all of our problems that we had before, how many triangles did we have? 2, and they were similar triangles. This is just one triangle. But what I have is an angle bisector that cuts your triangle into 2 pieces. Your pieces are not congruent, but they are going to be proportional. So once you have an angle bisector, it's going to make separate pieces where opposite sides are going to be proportional to each other. So I'm going to mark my picture as if it's congruent. They're not congruent, they're just proportional, okay? But what I mean is like your long side will be proportional to your long side, and this little base that gets cut into 2, your base side will be proportional to your base side. So again, I marked them as congruent, they're not congruent, but those are the pieces that we're going to match. Does that make sense? So I'm really not using the angle bisector in my problem anymore. That's because I don't have 2 triangles, and if I do, this is the exact same line. So that's the same thing over the same thing, and I don't want to use that twice. So what I want to use is I'm going to do AB, the long part, is proportional to BC, the long part. And then if I use my base pieces, since I did AB first, that's the left side of the triangle, I'm going to do AD first, since that's the left side of the triangle, over DC. Now, like I said, proportions are flexible, so there are other ways that you can set them up and you get the same answers. So as we go through these examples, if you do your proportion different, as long as when you cross multiply, you get the same first equation, you're good. All right? Okay, are we ready to try number 6? All right, so again, the difference with this picture is I just have one big triangle cut into 2. And it tells me in my directions that KM represents the angle bisector. So even though they didn't really draw the angle bisector pieces, they told us in our directions, so now we can use this theorem. So I can use many ways to set up this proportion, but if I start with 12, what would you guys put on bottom? 18, because 12 on the left is going to match 18 on the right. So now I'm going to go left to right again. What goes on the top? 4.8, and then what goes on the bottom? X. Like I said, there's other ways. You didn't have to start with the 12 on top. So if you started with a different number on top, as long as when you cross multiply, you end up with 12x equals 18 times 4.8, you did it correctly and your proportion is fine. All right? Go ahead and solve that. Use your calculator. As we're going through these, make sure you're doing your work. Your guys' class is pretty good, but I've been busting some kids just writing the answer and not the equations, which is not helpful in your notes. When you go back and look and there's only an answer and you don't know how you got there, not even worth it, right? Okay, Eliza, what'd you get?
X equals 7.2.
Good. Do we agree? Yep. 7.2. Perfect. All right, let's jump down to number 8. Number 8 is a little bit different. Yes, I still have my angle bisector just because it told me in my directions that KM is my angle bisector. But what piece do I need that I don't have from the previous problems? Ella? ML. How do I find this section ML, Ella?
You subtract 15 from 39.
Good. So if I do 39, the whole thing, minus 15, that's going to give me the missing chunk that I need, which is what? 24. Now that I have all my chunks, now I can set up my proportion here. Grady, can you set up a proportion for me?
Yeah, x over 36 is equal to 15 over 24.
Good. Nice job. Cross multiply, so 24x equals 15 times 36. Solve that on your own, see what you get. Sean, what'd you get?
22.5.
22.5. Do we agree? All right. Are we going too fast? No? Okay. Number 9 is very similar, but if I try to do what Jake did, it wasn't Jake, it was Ella. Ella, 39 minus 15, and I come over here, I don't have a number for where that 39 was. I just have an X. So how do I write this little ML missing piece that I need? Will?
5x?
Say it again?
0.5x?
No, because it's not necessarily cut into two like congruent pieces. Remember, it's an angle bisector, so I know the angles are the same, but that doesn't mean it's a median.
X minus 12.
There you go. So the whole thing is x, so if I just take 12 away from that, I'm good to go. Perfect. All right, I'm going to erase a little bit. So now, who can set up an equation for me? Charlie, why don't you set one up for me?
12 over x minus 12
Okay,
equals 18 over 30.
good. Perfect. Remember, proportions are flexible, so as long as whatever you wrote on your paper, when you cross multiply, you have the 18 multiplying to your x minus 12 and your 12 multiplying to your 30, you're good, okay? Now, when your 18 does multiply to x minus 12, what do I need to make sure I do with it? Distribute. So please distribute 18 times x gives me 18x, but what's 18 times 12? 216 equals 12 times 30. You guys got that one for me? 360. Go ahead and finish solving that. Renee, when you get an answer, let me know.
8.
Not 8. Maddie?
32.
32 is the correct answer here. Renee, check your work and let me know if you need help with your mistake. Any other questions? Are we good? Last one? Okay. So, I'll let you guys kind of take the lead on this one. who can set up a proportion that would work for me? You can set it up however you want to set it up. Carly?
3x minus 9 over x plus 11 equals 27 over 18.
Okay, let me double check the 18. Yep, that looks good. Okay, so what Carly did just to match up her proportion, she started with her side. So she did like left side or top to right side or bottom. So then she did top to bottom for her other side as well. So top to bottom. As long as your pieces match, your order matches, you are good to go. So we are going to have to distribute twice here. But as long as whatever proportion you did, you ended up with 27 times x plus 11 and 18 times 3x minus 9, you were good. Now if you notice in your directions, when you solve for x, we don't just have to solve for x. What do we actually need to solve for our final answer? KL. So go ahead and do both of those pieces. I'll give you a couple minutes, and then we'll go over the answer. Claire, what did you just get for x? Not your final answer, just x. 17. So x is 17. If we didn't get 17, then your KL was probably off. But when I do go on to KL, Corinne, what do I need to plug into? Do I do the 3x minus 9 or the x plus 11?
X plus 11.
So if I do x plus 11 or 17 plus 11, what was my final answer, Corinne?
28.
28. How many of us got there? Good? Any questions? Are we sure? How do we feel? Good? All right.